So till now we have studied about the heat convection and radiation basics. So from now on we will start heat conduction in detail. So as we have mentioned previously, let's give a heading of heat conduction. As we have mentioned previously also that heat conduction was defined as the transfer of thermal energy from the more energetic particles of a medium to the less energetic particles. But the condition was no bulk motion involved. No bulk motion there should be there for conduction heat transfer to take place, and conduction heat transfer can take place in solids, liquids, and gases provided the bulk motion is not there. This is the whole and sole condition for conduction heat transfer. So, so some points are there with respect to conduction that unlike temperature, unlike temperature, heat transfer is denoted by Q is vector. And what is vector? Which has both magnitude and direction. Okay, so whenever we specifying about the heat transfer, so we should specify the direction heat transfer. For example, if we are saying that heat flux of 50 watt per meter square is taking place on the potato, so it is very vague statement. We should specify that potato is getting heated or getting cooled by this specific amount of heat flux. So if we say that potato is getting heated at a rate of 50 watt per meter square, it means it is receiving heat. So it is a correct statement. So, so as we also know the driving force for any form of heat transfer is temperature difference, and same in the conduction. And temperature distribution is required in some of the heat transfer problems in engineering to calculate various properties like heat transfer rate, thermal expansion, thermal stresses at some critical locations and at specified times. So temperature distribution. Temperature distribution is nothing but the variation of temperature throughout the medium is the important objective of any heat transfer problem. So how we can find that we will see in this module, and why we are calculating the temperature distribution to calculate expansion, stresses, thermal stresses, and the heat transfer rate. So let's say this is a plate, and if we know the temperature uh, distribution on this plate at every point and at every time, we can answer all these questions, right? So, if we want to calculate the temperature distribution, we have to specify the temperature at every point, and for specifying the temperature, the specification specification of temperature in a medium we can specify. So we need two things: location, that at which location we specify the temperature, and the time. And if you come to here, the location we can specify in generally three main coordinate systems: Cartesian, cylindrical, and spherical. We will see what are these. So this is Cartesian coordinate, or we can say rectangular coordinates. This is any point in three-dimensional system. This is rectangular or Cartesian coordinate system. Similarly, we can define like cylindrical like this way. So this is the point. So mainly we have three things: R, phi, and z. So z is the vertical coordinate, means this along the axis of the cylinder, and r is the along the radial direction, and phi is the angle between x-axis and r. So if we see in two-dimensional in xy plane, then it will look like this: r phi. Similarly, spherical. So at any r like this is the point P r phi theta. So this is the angle between the vector of a point P from the origin, the angle between the z-axis and this vector is theta, and projecting this point in the xy plane, so we will get this coordinates. So x, y, and this is the r This is R, and how much this angle is phi. This is spherical, cylindrical. So temperature can be specified like and time. So we need position as well as time to specify the temperature. So I have specified rectangular coordinate system. So you can similarly specify a cylindrical and spherical coordinate system. So if we specifying the temperature like this, it means temperature in the medium of the body is changing with respect to x, y as well as time. Okay. Now we should understand what are the meaning of steady and unsteady heat transfer. Or transient. This is the name of unsteady. So let's suppose that this is a wall and we are maintaining some temperature at here 30 degrees Celsius and here at this wall is 15 degrees Celsius. Similarly, same wall 30 degrees Celsius, 15 degrees Celsius, and we are seeing that what is the amount of heat transfer which is taking place from this wall across this wall like this. Q1 is the rate of heat transfer through this wall. Let's say we are observing at 2 p.m. and say it is some heat transfer Q1, and let's say we observe the same wall at 5 p.m. and let's say that heat transfer to the wall was Q2 and it is not equal to Q1. If it is not equal to Q1, so this is unsteady heat transfer, transient heat transfer. It means that heat transfer is changing with time. Means we are observing the same walls, means same 2 point, and heat transfer was changing with time. So it was transient heat transfer. So transient means variation of any quantity with time.